All right, good afternoon, everyone, and welcome to the third webinar in our monthly series around Edge Cloud and Edge Computing. My name is Lauren Gibble. I am the Director of Growth Operations for Cox Edge, and I'm here today with my esteemed colleague, Josh Bradley, who is our Director of Technical Operations for Cox Edge. So throughout this year, we're exploring many different ways for developers and companies to leverage the strengths of a last mile edge infrastructure. And for today's focus, Josh is going to explain to us how Edge solves one of the most challenging problems when you're deploying Kubernetes. So throughout Josh's presentation, we will be keeping an eye out on the chat. So if you have any questions or comments, we look forward to seeing them come in throughout the discussion. And then when Josh wraps up his presentation, we will have a short Q&A session, and we'll try to address as many questions that you guys submit as we can. So that said, Josh, I will hand it over to you.
Cool. Thanks, Lauren. Hello, everybody. Today, we're going to talk about an issue with Kubernetes design and low latency. This slide shows a typical enterprise-level Kubernetes configuration with 3 control planes, 3 ingress nodes, and lots of worker nodes. We've always been able to spread around or distribute the ingress and worker nodes, but since the earliest days of Kubernetes, we've all had the same limitation around the control plane. All the control plane nodes needed to run for the best results in the same data center. Splitting that functionality, usually for high availability, was difficult and generally not recommended. The reason is that the control plane nodes usually host etcd. etcd is a distributed key value store, and it's the brain of Kubernetes. etcd stores the state and configuration of the Kubernetes cluster and the state of the hosted services, so it's pretty important. Every etcd node needs to be in sync with its other cluster members to stay healthy. If you try to separate etcd into different data centers, you can see issues with network latency. You could have issues with egress charges from all the communication between data centers, or you could see longer lead times for quorum consensus, or delays in replication. And maybe most importantly, if you lost quorum to a heartbeat timeout, you could get the split brain, where multiple etcd nodes have elected themselves as leaders and no one is sure which one is the source of record. And that would impact deployments and auto scaling and resiliency. The good news is we finally have a solution to the split brain problem. So etcd requirements haven't changed, but the network everyone can get access to has changed. Because if you deploy on a last mile edge architecture, you can finally split etcd across multiple regions and maintain very low latency and even keep your costs down. If I'm new to you, my name is Josh Bradley. I'm the Director of Technology and Security Operations for Cox Edge. I've been at Cox for 24 years, and I led my first production Kubernetes deployment in 2016. That deployment was the first of hundreds of deployments my team and I implemented for Cox. We haven't tackled every type of deployment, but so far we've run vanilla Kubernetes, Platform 9, OpenShift, Rancher, Docker Enterprise, and Google Anthos. We've also tried out lots of others, but every time we wanted to implement high availability, we always ran up against the split brain pain. Then, a couple years ago, Cox moved into Edge Cloud and possibilities started opening up. Now that we have a last mile edge network, we're running Kubernetes clusters across data centers pretty easily. Today, I'm going to show you how we do it and how you can too. Default etcd can get finicky when latency goes above 50 milliseconds. For a bit of reference, it takes at least twice that long to blink. As you can see in this chart, we have lots of options for etcd. Our implementations do have the same restriction that everybody has, the speed of light. That's a big hurdle. Plus, latency directly relates to user experience. The Internet of Things, smart cities, smart devices, they all have expectations and demands like never before. At Cox, we haven't worked out how to beat physics, but the latest generation of edge cloud companies are bringing their data centers into the market, and it's making a different solution possible. The infrastructure providers, the companies with nationwide networks, are moving into the edge cloud and edge computing market. They're turning up edge data centers in every metro area where they have a footprint. Where I work, turning all those up means we have data centers within 15 milliseconds of most of the eyeballs in the United States. With the older generation of cloud providers, you or your users might be hundreds of miles away from whatever data center they were using. That's why lately, When cloud providers say they're partnering with telecom carriers for optimal backbone performance, that means they're working with a company that owns thousands of miles of high-speed network, like Cox. Every infrastructure company, like your local telecom or broadband provider, has to be connected to millions of endpoints to provide service. That's done by having a lot of local data centers, usually in the same metro area as the user. And that's why it's called a last mile network. And it's why these companies that can offer ultra low latency, they don't overcome the speed of light, they blanket their footprints with local data centers connected by fiber. That's the solution. This ability for you to have access to data centers in your local market. It opens up a reliable option for distributed Kubernetes deployments, or really any service with low latency requirements or high processing demands. So when you're hosting Kubernetes deployments in close proximity data centers that have low latency communication with each other over a last mile edge network, you can treat multiple data centers like they're a single data center, but avoid the split brain issue. Because communication between them is so fast, it's like they're in a single location. Really, at these speeds, we're not even talking about low latency. We're talking about ultra low latency. It's so low, we see customers are even starting to move their on-premises compute and storage out to a local edge data center. These maps really tell the story. These are real numbers in milliseconds. These are round trip times between POPs or points of presence. The lower the number, the better. When your service is architected and tuned properly, and you have access to a nationwide backbone, you can treat locations around the country like they're local to each other. Cox Edge is currently in 31 data centers. We have 12 data center deployments underway, and our parent company, Cox Communications, has close to 300 locations nationwide, from large-scale data centers to very small ones located around the corner from some of our customers. So it's pretty easy to choose one that's close to you or close to your customer. Our customers in IoT, in healthcare, gaming, financial tech, and video are seeing immediate benefits from this. But now, ultra-low latency options are available to everyone. We're seeing all kinds of customers driving innovations with PubSub, with streaming, and with data gravity models. In just a bit, I'll show you how to set yourself up on our portal for free. Definitely check it out. It's a great option for etcd and other latency-sensitive services, and there's no reason you shouldn't check it out and take advantage of it. It's worth checking out just for the Edge database. It's distributed, it's got a lot of great features, and it opens up a lot of cool possibilities for your app or your service. All right, so how does this actually work? Let's look at this cluster setup and the latency you can expect to see with your own deployments. These nodes are hosted in different data centers along the Cox backbone. In this chart, you can see the data center to data center communication between Orange County, California, Las Vegas, and San Diego. The longest round trip takes less than 12 milliseconds because these metro areas are connected over our high-speed fiber backbone. We deployed 3 nodes at 3 different data centers. One node is hosting the control plane running etcd. The other 2 are standard worker nodes. You can have any number of worker ingress nodes in your setup. Well, as many as Kubernetes will let you anyway. The control plane is what we'll focus on, since that's where we usually have the most trouble. You can adjust this to your needs. Just make sure you always have an odd number of control plane nodes. You always want to make sure you have an odd number of control plane nodes so a quorum vote can have a clear winner. Once the nodes were deployed into different data centers, we set up a mesh network with point-to-point tunnels between each of the nodes. It's like a mesh network you could set up at home, just harder to configure. We are currently working on automating this virtual private cloud functionality to make this easier for us and for you. We'll have it validated in the near future. The rest of the steps are pretty standard cluster build. We installed Kubernetes and Docker. We added each node to the cluster in the appropriate role. What's really great is we didn't have to perform any tuning to make this work. All heartbeat and election intervals are left at the defaults. As you stretch this to data centers you choose across the nation, tune and test to get the results you want. I mentioned before that there are possible concerns like frequent elections or heartbeat timeouts. Those are usually just latency problems wearing different clothes. Keep your latency low and those issues won't come up. Overall, it's not too complicated, right? 1 cluster instead of 3, 3 control planes instead of 9. Now, doing what engineers do, we pushed it a bit to see how a nationwide 5 control plane cluster would work. So we added 2 control plane nodes, one in Rhode Island and one in Virginia. We're pushing it a bit, going up to 74 milliseconds, but we still have a healthy coast-to-coast etcd, which is pretty cool. What you see here is putting Kubernetes and all of us using it into a new place. We can have a single control plane configuration. We still have easier deployments and easier management, and we still have high availability and resiliency. We don't have to worry about cluster drift or service drift. We still have centralized management and deployments. And we get to use a common container network interface, a common storage interface, and a common ingress. And we know our nodes are all in sync because it's just regular daemon set deployments. Service resiliency is also easier to manage because we can now use disruption budgets, affinity and anti-affinity across data centers. These 5 nodes in this demo range from 200 miles apart to 2,500 miles apart. I picked these locations just for this demo. You can decide where your own workloads will run. Some providers don't let you pick your data center, or they charge extra to do that. If you need any help, we have an excellent customer success team to guide you with placement. I guess I should point out here that you don't have to manage Kubernetes yourself at all. There are firms that manage it for you, like Platform 9. We're working with them on a managed Kubernetes product. So if Kubernetes is new to you, or you're not interested in managing it as it gets more complex, remember that's an option. So to sum up, splitting etcd across data centers wasn't possible or recommended for as long as Kubernetes has been around. Now, even though Kubernetes hasn't changed, the network we have access to has. So split brain doesn't have to be an issue anymore, as long as you're using a last mile edge cloud service. Okay, before we jump over to questions, I really want to thank Google and the Cloud Native Computing Foundation for open sourcing Kubernetes. And thank you to all the contributors to this community. And finally, a big thank you to our network engineering, cloud, and edge teams at Cox for making all this happen. And thank you, everybody, for your time today. All right, with that, Lauren, back to you.
All right, thank you so much, Josh. That was incredibly informative, and I loved the visuals that you shared around how all of this actually works and how you guys were able to test the limits. So before we start answering questions, I did just want to share the QR code on the screen here. So if you scan this with your phone, it will take you to a sign up page where you can try Cox Edge for free. We also have innovation and developer incentives that are included there. And we are always happy to have one-on-one conversations with you to try to figure out the solution that will work best for you and ultimately your customers. So that said, let's go ahead and start with some questions. And we had several questions that were submitted via email when people registered for the webinar. So we'll start with those first. All right, Josh. So simple, straightforward question. Why don't we just use AWS ZKS?
That's a good question. I mean, you absolutely can. EKS is a great solution. There are many great solutions out there. You just have to look. You can't always pick the distro you want to run, and you may have to, have all your control planes in one availability zone and potentially pay more for your data center access. But it's a solution. Okay.
And on the topic of security, what is the security risk of having a cluster spread across multiple sites?
Security comes up. No, this is a very good concern. It's, I guess I'll give you the typical IT answer of it depends. It's how you look at it. A single cluster, you can manage that using a single set of tooling. It's one thing to, to monitor and look at. It's much easier to keep an eye on. When you have multiple clusters, you have multiple endpoints. You also have 3 times the amount of nodes to patch and things. So you do increase your blast radius a little bit with a single cluster. But, again, I guess it's just really how you look at it. But if you're using your standard, security toolings and deployments, it really shouldn't be that much of a difference. Just probably a little bit easier since you don't have as many nodes to manage.
Okay, great. And would this introduce a single point of failure with a single cluster?
Actually, it can, but it's again, I guess another depends on how you look at it kind of question. In the scenario, if you remember one of the first slides we showed you, we had the ingress and the worker nodes at local, and the control planes were split around. If you did have an issue with the control planes, all your services would still be able to work. All your ingress would go to the local spot. Your service would still be run on your local worker nodes. Of course, you'd have issues with scaling and things like that. But if you're really using solid CI/CD practices, continuous integration, continuous delivery, infrastructure as code, being able to restore a node or an entire cluster shouldn't really be that big a deal.
Okay, that's great. That's good to hear. And another question came in about a specific use case. So, can I split Kubernetes cluster between enterprise Kubernetes and Edge?
Thank you to whoever asked that. Yes, that's what we're looking for. So that's a great use case. We actually ran into something a couple of years ago where we had 2 data centers, and again, to go back to my odd number, you always want to have 3 for a quorum. So we had 2 data centers, and and we were really dying for a third one just to have that. So we could have taken advantage of our own stuff, and that's kind of why we launched. But yeah, absolutely. If you have 2 locations that you have infrastructure on, let's spin something up in the Cox Edge. We can throw another node out there. You've got your 3rd node. We can do 2 more and have 5 across the nation like we showed. But yeah, no, that's a great use case. You still get to use your on-premise, orchestration and services, but then you also get the the comfort of having something in the edge as well.
Great.
Really good idea.
And speaking of Cox Edge, a question came in. Does Cox Edge support any Kubernetes distro?
Okay, so in what we just showed, yes, because it's a DIY. So do it yourself. When you're installing your own Kubernetes, of course, you can do whatever version you want. That's a little more, Kubernetes skills are required to do that. The managed Kubernetes product that I referenced earlier, we will try and stay as close to current revision as possible for that, but just the ability to properly support it for our customers, train support staff and things like that, realistically we'll probably be a version or 2 behind. But again, it's a managed Kubernetes product that's made to be easier for you. So we want to do our diligence on our side to make sure we deliver a solid product. But again, if you install your own Kubernetes, go with whatever version you like.
Yep. And as we mentioned earlier, we have a customer success team that's happy to have those conversations about Cox Edge's capabilities with you guys. All right, let's try to hit a few more questions. So this question, want to get the Josh Bradley opinion on this. What is your view on K3's, MicroK8s, and Kube Edge? Do you think those will be more widely used on the edge?
Yeah, super cool. I love those technologies. Yeah, so I mean, anything Kubernetes I'm into. So they are great solutions. They're really, I see them as kind of the evolution for Kubernetes as the evolution for containers, right? So we took a VM, we stripped it down, we made it only lightweight, only do what we need. Well, that's what K3s and the smaller lightweight Kubernetes distros are doing. So really great, cool solutions. You still kind of run into the situation where you have multiple Kubernetes instances. Now, granted, there's some argument they're a little bit easier to manage because they're so lightweight, but you're still having to go out to multiple different instances. What we really showed you here is the ability to stand up a single Kubernetes cluster and have one endpoint management. So love those tools, really great tools, little different use case though than what we were presenting here.
Yep, okay. All right, and then last question to wrap us up. Why do we want this? What makes this valuable to businesses?
Absolutely. Yeah, the good question. Really, I think the biggest thing is availability and resiliency. I mean, you get, like I talked about earlier, you get the advantage of having ease of management, less infrastructure, less licensing, less nodes to support and stuff like that. But really, I think the resiliency and the availability is what really will sell this. This is really for, someone who wants, has a class 1 service, really wants uptime, really, an important service where their customers can't be down. This is a good use case for that. I guess I already talked about reducing per node licensing as well, but yeah, that's another good, option for them.
Okay. All right. Well, let me just check the chat, make sure we had no questions. Okay. So we are going to wrap up for today. Thank you so much, Josh. And thank you to everyone in the audience who joined us today. We will be publishing a follow-up blog post just addressing the questions that came in and some of the content that Josh covered today in his presentation. So keep an eye out on your email. You'll see that come in sometime in the next couple of days. So thanks everyone again, and hope you have a great rest of your Wednesday.
Thank you all.